Consider a cylinder of height h and radius a, closed at both ends, right, centered at the origin. R is given, the position vector R is given. Then the position vector and n cap b is the unit normal vector. Then we want to find the surface integral of these, right. So this is simple only. How? Surface integral of r dot ds you want to find. So to find the surface integral, we find volume integral. Why? See, to find the surface integral, this phase surface integral we want to find, this phase surface integral we want to find, and again the curved surface integral we want to find. Then we have to sum up all. For this, difficulty removed by applying divergence theorem. Surface integral is equal to what we studied, that is volume integral, the function, the vector field, that divergence you take, that is div r dot dv, right. This is the method we studied, right. Now see, what is div r? I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z, right. What is r? R is equal to position vector, that is given here, that is xi cap plus yj cap plus zk cap. When you solve this, x 1 I dot I 1, then 1 plus y dou by dou y of y 1 j dot j 1, right. That means again 1. Similarly z also doing 1, right. Then 3 is the answer. So this value is volume integral 3 dv, that is 3 into integral dv, that is 3v. dv on integration, volume of the cylinder. What is volume of the cylinder? Pi. What is the radius given? Radius of the cylinder of radius a given, right. Then pi a square h, height h also given, right. Then pi r square h is the, pi a square h is the volume. Then 3 pi a square h is the answer. Which is the option? Option B is correct, right.